Hello to all of you. This is Dr. Dhaval Maheta, and today we will understand how to split the data into training and testing data set while running deep learning algorithm in Rapidminer. So the deep learning is a subset of a machine learning, which is essentially a neural network with three or more layers. These neural networks attempt to simulate the behavior of the human brain, albeit far from matching its ability, allowing it to learn from the large amounts of data. Deep learning is a machine learning technique that teaches computers to do what comes naturally to humans. Just by an example, deep learning is a key technology behind driverless cars, enabling them to recognize a stop sign or to distinguish a pedestrian from a lamppost. It is a key to voice control in consumer devices like phones, tablets, TVs, and hands-free speakers. Deep learning is getting a lot of attention these days, and it is also for the good reason because the accuracy achieved in deep learning is much higher. Now, what's the whole concept? Let's try to understand in the next slide. In case of machine learning, the feature extraction is done first, and then it is fed to the classification algorithm. But the deep learning takes care of the feature extraction also. The deep learning is a combination of feature extraction plus the classification. Now, how we can do this in Rapidminer? Let's see. For this, we will go in the process area and I'll load the data set part 1. Press the play button. Now you can see here the attributes which are there in this data set are age, gender, chest pain type, resting blood pressure, cholesterol, fasting blood sugar, resting ECG, max HR, exercise, old peak, ST slope, a patient is having a heart disease or not, yes or no. So on the basis of these attributes, I want to classify that a patient is having a heart disease or not. So I'll go in design and now I'll activate the select attribute operator. It is necessary to activate this operator because your data set may be having many attributes and we don't want to include all of them in our analysis. So I'll drop the select attributes here. I'll activate the subsetting from here, select the attributes. Now I'll select those attributes from which I want to make the model. So age, cholesterol, fasting blood sugar, heart disease, old peak, and resting blood pressure. Transfer it here, apply. Now I'll activate set role operator. So I'll drop it here, set role operator. Deep learning falls in the category of supervised learning technique where we have to specify the target variable or the dependent variable. So I'll go here and activate heart disease and the target role is specified as label. Now I'll split the data into training and testing data set. So for this, I'll activate the split data operator from here. I'll drop it here. Activate the operator, click on edit enumeration. I want to split the data 70% for training and 30% for testing. Okay. Now I'll activate the deep learning operator from here. Drop it here. Now the 70% has gone into the deep learning algorithm. Remaining 30% will be used for testing the data set. So I'll apply the model here. I'll disconnect this spline. I'll connect model with model. So 70% has gone in training. Remaining 30% will go in testing data set. Now I'll activate the performance from here. Deep learning comes under the classification algorithm and therefore you will have to activate performance classification operator. Connect label with label, performance with the result, model with the result, and press the play button. Now here you have to see the performance vector. Now this 72, what does it mean? Let's try to understand. A person was not having a heart disease and the algorithm also predicted that the person is not having the heart disease. So 72 cases were correctly classified. Here, a person was having a heart disease. true, yes. And the prediction was also there that yes, the algorithm predicted the person is having a heart disease on the basis of the attributes. So 72 plus 133 are correctly classified cases. So our classification accuracy is 74.55%. But if I talk about this, a person was having a heart disease, but the algorithm predicted no. Here, a person was not having a heart disease, but the algorithm predicted yes. Basically, these are leakages in the model, or rather, we can say this is a misclassification which has happened, which is not desirable. If we talk about 58.5%, this is the classification accuracy in only no, that is for no category, and this is a classification accuracy for only yes category. So this is a way you can split the data and evaluate the performance of deep learning in Rapidminer. For more videos on Rapidminer, kindly subscribe to my channel. You can see my playlist in which I have already uploaded many videos of Rapidminer. Please don't forget to press the like button. You can also follow me on Twitter and LinkedIn.